Hi guys, welcome back to my mathematics tutorial. And my name is Peter C. Dogwood Jr., your mathematics tutor and an instructor of mathematics at the University of Liberia. In my today's lesson, I will be discussing differential equations. Particularly, I will be looking at variable separable under the first order, first degree differential equation. In previous lessons, we did few problems under separable variables differential equation method. And in this lecture, we want to look at an additional problem. That is the 20th problem on a variable separable when considering first order and first degree ordinary differential equation. So let's get started. Please pay attention. It's not difficult. It's very, very easy, but you just have to pay keen attention. Now we have the square root of 1 plus x squared plus y squared plus x squared plus y squared plus x y prime equals to 0. So we have this to be a differential equation. Now we know that this is a differential equation because of this y prime. If there was no y prime here, it means that this is not a differential equation. So the next thing we need to do is to ensure that we separate the variables. Now we have two variables here, x and y. So we want to make sure that we separate all of the expressions in x on one side of the equation and all of the expressions in y on the other side of the equation. So to firstly do that, we must apply some algebraic simplification right in here, that is to factorize. So we can factor by grouping in here. We group the first two terms, 1 plus x squared plus y squared plus x squared y squared. So we group the first two terms and the last two terms plus y prime equals to 0. So the next thing we need to do is to factor out what is common. So we have 1 plus x squared and then plus y squared. So we can bring it outside. We're left with 1 plus x squared. Or let's say plus y prime. Now this y prime can just be changed to dy by dx equals to 0. So we can factor out this is common to the two of them. While doing that, we can also multiply outside by dx to get rid of this dx down here. So if we multiply this dx by this one, but in doing that, we can factor out 1 plus x squared. So what will be left over? So if this comes outside like this, you left with 1 right there. And then this into this cancel, you left with y squared times dx. And then dx times this, dx and dx will cancel. You left with x, y, dy equals to 0. So now we can maintain these terms and it has y. That's just my style. I will always want to have y on the left since y is a kind of name of the function and x is the variable within the function. So I want y to be on the left hand side so that if it is possible that I solve for y at the end, it cannot give me any difficult time, or it can be arranged in a way that everyone can be able to understand my solution. So I send this term across, it becomes negative, the root of 1 plus x squared times 1 plus y squared. Now this 1 plus x squared and 1 plus y squared, let's just go faster. We can, when you have a times b, the root of a times b, you can rewrite it as the root of a times the root of b. So we can allow each of them under one radical, under their own radical. So we have 1 plus y squared times dx. So since this is dy, all we need right here is only y. So this x, we divide both sides by x. When this is the x, we need only x. So this is, we need to get rid of this one. So this and this will cancel. And then y and y. So we divide this one also on this side, 1 plus y squared. So we'll now be left with y dy all over the root of 1 plus y squared equals negative the root of 1 plus x squared all over x dx. So because the variables have been separated now, we can integrate both sides. So by integrating both sides, for this area, we can apply u substitution. We can say let u equals to the entire denominator, 1 plus y squared. Now, if we square both sides, we're going to get u squared equals to 1 plus y squared, right? So after squaring both sides, if we can differentiate on both sides, we have 2u du is equals to 2y dy. So we divide both sides by 2. So this 2 and this 2 will just go out. So 2 will just go out. And then we'll be left with u equals to du. And then let's say u du equals to y dy. So that's the first case for this first integral. We're going to apply the substitution right here. Now the next integral we can do is to rationalize. So we can rationalize the root of 1 plus x squared. And we rationalize the root of 1 plus x squared, thereby saying the root of 1 plus x squared divided by the root of 1 plus x squared. So you notice that we've just multiplied this entire integral by 1 because this divided by itself is just 1. So now the result now will lead to, so the first case, we have y dy is just equal to u du all over this denominator now is just u equals negative. Now the integral of, now whenever we multiply two radicals, we take the radicand, that is what is under the radical. So it's just 1 plus x squared all over x times this is just x, the root of 1 plus x squared dx. So this u can cancel this u. You have the integral of the u negative. Now we can open this up. You have 1 all over x, the root of 1 plus x squared dx minus the integral of x squared all over x times 1 plus x squared dx. So the integral of this is just u minus. Now, there is a property that states that the integral of 1 all over, let's say a squared, or let's use x squared plus a squared is just equal to the ln of a, not a number x. So we will have, the space is too small. Okay, let's do it down. This is equal to the ln of x plus the root of x squared plus a squared. So we have this integral property. So we want to see how best we can simplify this expression so that we arrive at that property, since we have the square root of this. So to do that, what we can do first is that we can factor out x squared right here. If we factor out x squared, you will have x squared into 1, just like 1 all over x squared. And then plus x squared into x squared is just 1. Right? Then we have minus. Now, so this x, we cancel 1x from here, you left with x. So for this case, now what you can do, you can say, let my u, or let's say v equals to the root of 1 plus x squared. So we take the square root on both sides, v squared will just be equal to 1 plus x squared. We differentiate both sides, we have 2v, the v is equal to 2x dx. So 2 and 2 will just cancel. You have v dv equals to x dx. So this is for this one. So if we put it in, we'll have the integral of, now this x dx is just equal to v dv. And then down here now is just u. Now we are using v, so it's just v. So v will cancel v, and we'll be left with dv. So we have u equals minus the integral of 1 all over x. Now, the square root of this x is just x. So x times x will give us x squared. And then the root of 1 all over x squared plus 1 all over x. So this 1 over x squared, we can rewrite it as, now this is just 1. We can rewrite this 1 over x squared as 1 all over x all squared dx minus, now the integral of dv is just equals to v. Now the reason why we rewrite this thing like this is because we want to substitute. We want to bring in some u substitution, because if we say let our u be 1 over x, we know that the derivative of 1 over x is negative 1 over x squared. So that negative 1 over x squared, we can get it from here because it's negative 1 over x squared dx. So that's the reason why we apply that particular factoring. And that's exactly what we're heading now to the solution of the problem. So we have u. Now let's know what we represented u first for. U was the square root of 1 plus y squared, right? So let's keep that. Initially, we said u equals to the square root of 1 plus y squared. So we want to keep it for now so that we don't have too many things to be writing. And we said v is equals to the square root of 1 plus x squared. Okay, so those are the two things that we know. Now, we have u equals minus the integral of, so this minus now, we can even say, let's attach it to that dx, and this is 1 all over the root of 1 over x all square plus 1. So times, now, negative 1 over x squared dx, which is this expression now. This, we just put this one on the side. So this entire expression right here, right? If you allow your u, or since we have used u already, we can say let t equals to 1 over x squared, 1 over x. So if we differentiate u, the u equals, we can even use the quotient rule, right? We hold this x, we differentiate 1, we get 0. Minus, we hold 1, we differentiate x, we get 1. Divided by x all square. So this one go out. So it's just like saying negative 1 all over x squared dx, because you have differentiated with respect to x. So you see this one? So du now will just be equal to this whole portion is our du. And then this 1 over x will just be equal to u plus 1. So we can see that it will be x squared plus a squared. Then we can bring in that property. So now we have u equals, now the last portion, we can't forget it, minus v. So it's u equals to the integral of, now this numerator now is just du divided by the square root of u squared plus 1. Not u, now we use t, right? So it's t squared plus 1. So this 1 can be rewritten as 1 squared, so that you see that it appears in that form. And so minus v. So we know that our u is 1, the root of 1 plus y squared equals, Now this entire expression now is just the ln of t, according to the formula, plus the root of t squared plus 1 minus v is just the root of 1 plus s squared plus some arbitrary constant c. So you see, this is actually our general solution. But if we want to maybe further simplify it now, we can do that. But this is our general solution. But remember, you used a new variable to be able to manipulate the problem in this area right there. So we substituted 1 over x with some t. So don't forget, okay, yeah, we said this is t. Let's use t because we already had u already. So we said let's use t, right? Okay. So t now is being substituted for 1 over x. So that's how we got the dt. So this whole portion ended in dt. So we need to bring in the value of t. So we have 1, the root of 1 plus y squared equals the ln of t. What is t? T was just 1 over x. 1 over x plus the root of 1 over t squared plus 1 minus, okay, the root of 1 plus x squared plus some arbitrary constant c. So this is our general solution of the differential equation. So thanks ever so much for watching. Please don't forget to subscribe to our channel, like our videos, hit the notification button so that you get updates on new uploads. Thank you. See you in our next lecture. Math is fun. Let's always have fun. Don't forget. Always have fun. Fun.